My dear students, today I am going to discuss this chapter of maths, sets. This is included for syllabus of class 11. Now this is a second video, continuation from my last video which I uploaded a couple of days ago. Alright. Now today I'll start from subsets and supersets. So subsets and supersets. Okay. Now suppose this is a set of these elements. A is a set of suppose 2, 4 and 6. Alright. Then B is a set of 2, 4, 6, 8. Now each and every element of A are present in B. So 2 belongs to A, 2 also belongs to this set. 4 belongs to this set, 4 belongs to this set. 6 belongs to this set, 6 belongs to this set. So each and every element of set A belongs to set B. So each and every element of set A is present in set B. In such a situation, we say A is a subset of B. And this is a symbol of subset. So this one is a symbol of subset. Alright. This is a symbol of subset. Now A is a subset of B. Why? Because each and every element of A is present in B. Each and every element of A belongs to B. Now if A is a subset of B, conversely we say B is a superset of A. So we write B is a superset of A. So this is a symbol of superset. This is a symbol of subset. This is a symbol of superset. Now when you say B is a superset of A, it means B contains all the elements of A. B contains all the elements of A. So 2, 4, 6. So they are contained in B. So B contains all the elements of A. Therefore B is a superset of A. And all the elements of A are present in B. Therefore A is a subset of B. So if A is a subset of B, then conversely we can say B is a superset of A. So that way, subset and superset. Alright. Then suppose now suppose this one, that is A is this, suppose A is 2, 4, 6 and there is another set, suppose C. So C is suppose 2, 6, 4. Alright. Now this set and this set. So just look at these two sets. Now what is the relation between A and C? Now each and every element of A are present in C. So 2 is here, 4 is here, 6 is here. Alright. Therefore A is a subset of C. So A is a subset of C. Why? Because each and every element of A is present in C. And conversely, each and every element of C present in A. See, 2 is present here, 6 is present here, 4 is present here. That means C is a subset of A. So A is a subset of C because all the elements of A are present in C, and also C is a subset of A because all the elements of C are present in A. That means they are subsets of each other. A is a subset of C and C is a subset of A. If two sets are subsets of each other, that means they are equal. Therefore, A is equal to C. Now, equal set I discussed in my previous video. So, two sets are equal when they contain exactly the same number of exactly the same elements. So, 2, 4, 6. Here 2, 4, 6. The order is not important. So, these two are therefore equal. So, if two sets are subsets of each other, A is subset of C and also C subset of A, they are subsets of each other. In that case, what? They must be equal. All right. And this is why there is an important conclusion. Every set is subset of itself. Subset of itself. So this is a very important conclusion. Every set is a subset of itself. Now, if we call this one A, this one also we can call A because they are equal. All right. If this is A containing 2, 4, 6, this is also A containing 2, 4, 6. Okay. That means in place of C now we can write what? A. So what result we get? A is a subset of A. A is a subset of A. That means every set is a subset of itself. If every set is a subset of itself, then every set will be a superset of itself. All right. Therefore, every set is also superset of itself. Superset of itself. If A is subset of A, that means A is superset of A. Conversely, if A is subset of A, then A is superset of A. Okay. So every set is subset of itself, and every set therefore is also superset of itself. Okay. Now, null set. Null set is considered subset of every set. So this is a very important conclusion. So null set. Now null set I discussed in my previous video. This is a symbol of null set, Greek letter phi. So what is null set? Null set is a set which does not contain any element. That means number of elements 0, isn't it? So this is a null set. So last time I discussed, that means it is a set of no element. Now null set is considered subset of itself, subset of all sets. Null set is a subset of every set. So null set is subset of every set. Therefore, every set is superset of null set. Null set is a subset of every set. Therefore, every set is a superset of null set, isn't it? Now, sometimes in the exam they ask you, why null set is a subset of every set? Okay. Now, why null set is a subset of every set? Suppose, consider this set. This set, suppose P, which contains, suppose these 3 elements, 1, 1, 3, suppose 5. Okay. Then this is null set. Null set means it has no element. Now, this null set is a subset of P. So this null set, this or this null set is a subset of P. Now, according to definition of this, suppose when you say A is a subset of B, so what does it mean? Each and every element of A is present in B. Each and every element of A is present in B. So A is a subset of B. That is the meaning, isn't it? Each and every element of A is present in B. Now we can say it another way. There is A does not contain any element which is not in B. If A is a subset of B, we may say the meaning this way also. A does not contain any element which is not present in B. Each and every element of A is present in B. That means A does not contain any element which is not there in B. Now that second argument we can use here. So why this phi is a subset of every set, suppose P? Because phi does not contain any element which is not present in P. Now this phi, null set has no element. So that no element, how can it be present in P? Therefore, that statement is true. Which statement is true? There is no element, there is no this null set does not contain any element which is not in P. Again, let me say it. Null set does not contain any element which is not present in P. Therefore, null set is a subset of P. So if you have to answer the question why null set is a subset of P, so your answer will be this. Null set does not contain any element which is not present in P. Obviously, null set has no element. Therefore, that no element, how can it be present in P? Obviously, isn't it? So this is why null set is considered subset of any set, subset of every set. Therefore, conversely, Null set is a subset of every set. Therefore, conversely, every set is a superset of null set. Okay. All right. Now, so this is subset, then not subset. So the symbol of not subset is this. So this is a symbol of subset. This is a symbol of not subset. This is a symbol of superset. This is a symbol of not superset. For example, suppose A is this. A is 1, 2, 3. And suppose B is 1, 1, 2, 5, suppose. Now, we cannot say it is a subset of B because A has 1, 2, 3. Now, this 1, 2, 3, 1 is present, 2 is present, but 3 is not present here. So, each and every element of A not present in B. Only 1 and 2 are present, 3 is not present. Therefore, A is not a subset of B. Therefore, A is not a subset of B. If A is not a subset of B, conversely, B is not a superset of A. Alright. So, note these symbols, not subset and not superset. A is not subset of B. Therefore, B is not a superset of A. Alright. These notations you have to use correctly because you cannot use any other notation. Is it clear? Okay. Now, every set is a subset of itself. That already I explained. Every set is a subset of these facts you have to remember. Every set is a subset of itself, and therefore every set is a superset of itself. Okay. Now, next, number of subsets. For number of subsets, there is a formula 2 to the power n. This is the formula for number of subsets. Now, suppose this is the set A containing the letters, suppose P, Q, R. So, this is a set of suppose 3 letters. All right. Now, here n is 3. So, here n means number of elements. So, how many elements? It has 3 elements. So, if n is 3, then this will be what? 2 to the power 3, that means 8. So, this set A has how many subsets? 8. So, how to find number of subsets? This is a formula. So, number of subsets of a set is equal to 2 to the power n, where n is the number of elements in that set. Similarly, suppose this set B. Suppose B has just 4 and 6. So, there are 2 elements. Therefore, what will be number of subsets? 2 to the power 2. That means 4. So, this has how many subsets? 4. This has how many subsets? 3. That way, suppose this set has only 1 element. Therefore, what will be the number of subsets? 2 to the power 1, that means 2. Alright. That way, suppose null set. Yes, come to null set. Null set has how many elements? 0. Therefore, how many subset it has? 2 to the power 0, that means 1. So, null set has no element, that means 0 element. So, 2 to the power 0, 1, it has 1 subset. C, this set has 1 element. So, it has 2 to the power 1, 2 subsets. This has 2 elements. So, it has how many subsets? 2 square, 4. 2 to the power 2, 4, this formula. And A has how many elements? 3 elements. Therefore, it has how many subsets? 2 to the power 3, 8. So, if there are 4 elements, then there will be 2 to the power 4. That means 16 subsets. So, this is the formula, right? Now, let us see which are the subsets of these sets. Now, suppose this, let us see the subsets. So, it is supposed to have how many subsets? 8. Now, which are the subsets? This is the first subset. This is the second subset. This is the third subset. Then PQ, then QR, then PR. So, PQR taking 1 element each, then taking 2 elements each, PQ, PR, QR, PQ, PR, QR. Then all the 3 elements. That means PQR. And of course, the null set. See how many? 1, 2, 3, 4, 5, 6, 7, 8. So these 8 are subsets of A. Now why this is a subset of this? Because you see every element of this set present here. Why this is a subset? Why PQ is a subset of this? Because every element of this set present here. So why PR? Why this is a subset of PQR? Because every element, there is PR present here, isn't it? Then every set is a subset of itself. PQR, this is PQR. All right. So this is a subset of itself, and then that statement, that fact that null set is a subset of every set. All right. So these 8 are subsets of A. So using this formula. Now let us see this one using, suppose there are 2 elements, then 4, this is the first subset, then 6, this is the second subset, then, so taking 1 at a time, 4 and 6, taking 2 at a time, 4, 6, and then just null set. So you see, so it has 2 elements, therefore 2 to the power 2, that is 2 square 4, it has 4 subsets. Which 4? 1, 2, 3, 4. Taking 1 at a time, taking 2 at a time, and then taking the null set. Okay, so 4 sets. So this will have only 2 to the power, that means 2. So which subset this has? It has null set and then itself, that is this one. So this has 2 subsets, null set and itself. And this has which subsets? This is 0, number of elements 0. So 2 to the power 0 is 1. So it has 1 subset, which this null set itself. So null set has 1 subset itself. This has 2 subsets. So you see, null set is a subset of every set. Null set is a subset of every set. Okay. So this is about number of subsets. To calculate number of subsets, that is the formula. All right. Okay. Then yes. Next, proper subset and proper superset. So you have learned subset and superset. Now this word proper subset and proper superset. Yes. Now suppose this set A, it contains 1, 2, 3. All right. And suppose B contains 1, 2, 3, and say 5. Now A is a subset of B, no doubt, but A is a proper subset of B. So proper subset. So proper subset and proper superset. Proper subset and proper superset. Now A is a proper subset of B. Why? Because all these elements are present in B. Not only that, there is at least one extra element. What is extra element? 5. So there should be at least one additional element, extra element in the second set. So then we say A is a proper subset of B. Symbol is that only. Symbol is this. This is also used for proper subset, proper superset. Now, if A is a proper subset of B, then B will be proper subset of A. Proper superset of A. If A is a proper subset of B, then B will be proper superset of A. Now, why B is a proper superset of A? Because B contains all the elements of A plus one extra, at least one extra. So here there is one extra element, 5. There may be more than one element extra. There may be 1, 2, 3, etc. So if this is to be this is a proper superset. This is a proper superset of this because it contains all the elements of this set plus one additional element. At least one additional element should be there. All right. That way, suppose this one. So this is the set of vowels. This is a set of vowels, and suppose A is a set of all the alphabets. All the alphabets, that is A, B, C, D, etc. Then at last X, Y, Z. Okay. Now see these two sets. V is a set of vowels, A, E, I, O, U, and A is a set of all the letters in the English alphabet. That means A is a set of alphabet. Now you see, I have written in roster form. You note it. So it is not possible to write. I mean, it is difficult to write all the 26 letters. It will be very long. Therefore, we can write this way also. This is another way of writing. So A, B, C, and then 3 dots and then X. That means in between there are the other letters. It is understood. Do not think this has only 1, 2, 3, 4, 5, 6, 7 elements. It has all the 26 elements. In between those, we are not writing because it will be too long. So note this method of writing. So V is a set of all the vowels and A is a set of all the English letters. A is a set of alphabet. Therefore, what V is a proper subset of E, because all the elements of V are present in A plus how many extra? 21 extra. There are 21 extra because this has total 26 and this is 5. 21 extra elements. So if V is a proper subset of A, then A must be proper superset of V. So V is proper subset of A and A is proper superset of V. All right. That way, N is proper subset of R. This is a set of natural numbers or counting numbers. The set of counting numbers is proper subset of R. R is a set of real numbers. Not only that, so N is also proper subset of Z. Z is a set of integers. Z is a set of integers. All right. So N is set of natural numbers. So this is a subset of Z. And then Z is a proper subset of R. Then Q is a superset. Q is proper subset of R. Rational numbers, all the rational numbers, that set is proper subset of R. So these letters you should be acquainted with. This is a set of natural numbers, proper subset of R. Set of natural numbers, proper subset of integers. Set of integers, proper subset of real numbers. Then set of rational numbers, proper subset of real numbers. Okay. So if Z is proper subset of R, then R should be proper superset of Z. The converse is true. So R is proper superset of Q. Z is proper superset of N. Okay. So that way the idea of proper subset and proper superset. Okay. All right. Then next, coming to singleton set. Singleton set. Now single means one. Therefore, what is a singleton set? So it is very clear from the name. Single means one. So a set of only one element. Suppose this is a set of, yes, suppose A is a set of one letter P. This is a singleton set. So this is a singleton set. Singleton set, or it is called simply singleton. You can say singleton set or simply singleton. Okay. Now what is a singleton? It is a set of containing only one element. So this one is a set of containing only one element. That way, suppose B. So this is a set of, suppose the number 5. So these are examples of a singleton set. That means a set containing only one element. So very simple. Okay. Yeah, that way phi also is a singleton set. All right. Okay. So set of only phi is not a singleton set because phi has no element. So singleton set will be a set of only one element. So very simple. Okay. Then next comes set of sets. Set of sets. Yes. Now see this A. Suppose we have these two sets. Suppose A is a singleton set. B is a, suppose again another set of two elements. Suppose and C is a set, suppose containing three elements. Okay. These three are sets. This is a singleton set. This is containing two elements. This is containing three elements. Now each of them is a set. Now, yeah, consider this set. So this P is called set of sets. Why P is called set of sets? Because every element is a set. See, A is a set, B is a set, C is a set. Now P is a set containing these three elements A, B, C, and all the three elements are what? Sets. This is why it is called set of sets. Now if you want to write using this braces, then you will write this way. So what is P? It is a set A. Now what is A? 5. So first set is 5, A. Second set B, this one. And third element is C. Now C is a set 9, 8, 7. As you see. So P is a set of these three sets. Now, this set is an element of P. This set is an element of P. This set is an element of P. So in set of sets, every element is what? Every element is a set. In set of sets, every element is itself a set. So P has these three elements. Which three elements? A, B, C. Each of them is a set. All right. This is a set of sets. So how will you define set of sets? So set of sets is a set in which every element is a set. Like this P, every element is a set. Okay. So this is a set of sets. Similarly, suppose this one. Suppose another set. Suppose R. Okay. R is what? Yes. Now you see, this is also R is a set of sets, because R is a set containing one element, phi. Now phi itself is a set. Therefore R is a set of set. Which set? Null set. So if you want to expand it, how will you write? Null set. Null set is this one without any element. So this is R. So R is a set of what? Empty set or null set. So this is a set of sets. This is a set of, this is obviously a singleton. This set has only one element, no? Only one element, phi. Therefore it is also a singleton. But it is a set of sets. Okay. All right. Then comes power set. Power set. Now power set is a set which contains all the subsets of a set as element. Now suppose this set, suppose set A has these two letters, suppose P and Q. Now this is a set of two letters. This is a set of two elements. This is a set of two elements. Therefore it will have how many subsets? 2 to the power 2. That means it will have 4 subsets. Which 4 subsets? Let us see the subsets. So subsets of this will be taking one element, already I showed before you, then taking one element, then taking two element. Taking two element means itself A, and then null set. All right. So this set A has how many subsets? 4 subsets. Which 4 subsets? Taking one element, this, taking one element, this, taking two elements. Two element means itself, and then this. So we can also write this way. In place of this, we can write just A also. So this set has 4 subsets. Which 4 subsets? This one, then null set, and itself. Itself means this A. Now, so this set containing all the subsets as elements. Suppose this subset is the first element, this subset is the second element, this subset is a third element, A is a third element. That means itself is a third element, and then 5, 4. So this A set has 4 subsets, and this B is a set of sets. It is a set of all the subsets. Definitely it is a set of sets because each element is a set. So B is called power set of A, power set of N. And how to write it? This PA. This is a symbol of power set. So PA means what? PA means power set of A. Now do not confuse with this Na. So there was in the last video I showed you another symbol. So see the difference. Na means number of elements in A. So Na is 2. When you write Na, it means number of elements in A. Number of elements in A. A has how many elements? 2. So Na is 2. That is the meaning of this symbol. But when you write Pa, Pa means power set of A. Power set of A. So what is the power set of A? This one. So power set of A has how many elements? 4 elements, and each element is a set. And each element is what set? Which set? Subsets of A. All right. Then suppose there are 3 elements. Suppose there are 3 elements. Let us see the power set of this. Now suppose this set A has 3 elements. Suppose 2, 4, 6. So it will have how many subsets? 2 to the power 3. That means 8 subsets. It will have 8 subsets. Now which are the subsets? Now let us write the power set of A. Let us write the power set of A. The power set of A is the set containing all the subsets of A. All the 8 subsets of A. Which are the 8 subsets of A? First of all, taking one at a time, this one. All right. Taking one at a time. Okay. Then taking 2 at a time. Okay. Then taking 3 at a time. 2 at a time, one more. 2, 4, 4, 6, and 2, 6. And 2, 6. Okay. Then taking 3 at a time. Now 3 at a time. 3 at a time means itself. 3 at a time means itself. Isn't it? So taking 1 at a time, these 3 subsets. Taking 2 at a time, these 3 subsets. Now taking 3 at a time, that means itself. So we can write simply A. All right. And then null set. Because null set is a subset of every set. So you see, this is the power set of A. Now power set of A will have how many elements? 8 elements. All the 8 subsets. 1, 2, 3, 4, 5, 6, 7, 8. Itself and null set. So these 8, each of them is a subset. Therefore, power set of A is a set of sets. Set of what sets? Set of all the subsets of A. So since there are 3 elements, there will be how many subsets? 2 to the power 3. That formula 2 to the power n, 2 to the power 3. There will be 8 subsets. And these are the 8 subsets of set A. And therefore, power set of A will be this large set which contains all the subsets as elements. So here each subset is an element. So there are 8 elements. So this is called power set. All right. Okay. Then what is the power set of null set? Power set of null set. Now null set has only one subset. So I showed you before, this null set has only one subset. So this is null set has only one subset, this one itself. Null set has only one subset, that is it. Because null set has how many elements? 0 elements. So 2 to the power 0 is 1. So null set has how many subsets? 2 to the power 0, that means 1. So it has only one subset, this subset. Therefore, power set of null set will be what? This one. All right, this one, or that means this one. If you want to expand, so it is very interesting to see. So power set of null set, it has only one subset. Null set has only one subset. This is a subset. All right. So this one. So power set, yes. Subset of itself. So this one, yes. Okay. All right. Then expanded form is this one. Extended form will be that one. So this null set is empty set, isn't it? So this is a power set of null set. All right. Okay, then last of all, universal set. At last, universal set. Universal set. Now, universal set is the largest possible superset of a few sets that are under discussion. Suppose we are discussing a few sets. So we are discussing set of vowels, set of consonants, then set of the letters in the word man, then the set of the last three letters. Now, what is a set of vowels? A, E, I, O, U, isn't it? Okay, then what is a set of consonants? All the 21 letters. So how many consonants are there? 21. So all the 21 elements, this set of consonants. Then M is a set of letters in the word man. So M is a set of the letters in the word man. And then X is a set of the last three letters. Which are the last three letters? X, Y, Z. Suppose for some reason you are discussing these four sets. So there is some reason for which you are discussing these four sets. Now these four sets are subset of the set of alphabets. The set of alphabets, isn't it? The set of alphabet is a superset, proper superset of all these four subsets. Because this V is a proper subset of alphabet, the set of alphabets, suppose we call it L. The set of alphabet, the set of all the 26 letters, suppose we call it L. Then V is a subset of L. B is a subset of, proper subset of L. C is a proper subset of L. M is a proper subset of L. And also X is a proper subset of L. So all these four sets under discussion for some reason are proper subsets of this set L, which is the set of alphabet. So this L will be called the universal set. Universal set. Why L is called universal set? Because it is the proper superset. It is the proper superset of all these four sets which are under discussion. Right. That way, when you are discussing the set of natural numbers, set of rational numbers, set of irrational numbers, set of integers. So these are the four sets, say set of natural numbers, set of rational numbers, set of irrational numbers, and set of integers, and set of whole numbers. Now all these five sets are proper subsets. Each of them is proper subset of what? The set of real numbers. Each of them is a proper subset of real numbers. That means the set of real numbers is proper superset. The set of real numbers is proper superset of these four. Therefore, this R will be called what? Universal set. Universal set. So when you are discussing these five sets, set of natural numbers, set of rational numbers, set of irrational numbers, set of integers, set of whole numbers, then set of real numbers will be considered as universal set, because set of real numbers is a proper superset. This is a proper superset of all these sets. So it will be considered what? Universal sets. So that is the idea of universal set. Okay, so today I'll stop here, but it will continue. There are many more things to discuss. So next time I'll discuss the third video. I'll make the third video on sets. Okay. All right, today I'll stop here. Thank you.